And once you do that, how do you move around and interact in that environment? That is a question that will be tackled by this panel today. So without further ado, I'd like to introduce this panel and Jason Jerald, who will be the moderator. So let's give a round of applause.
Welcome back. What a great keynote by Philip Rosedale. Let's get more of the hand. See where it takes us in the next few years. As Bruce mentioned, my name is Jason Jerald of NextGen Interactions, and we have an amazing panel here. We're going to be speaking about user input as well as locomotion. That is, what do we do with that input? We have to navigate through the world in some way. And what we'll have is each of the speakers I'll introduce them, and they'll give maybe a minute or so talking about kind of an overview of where they see user input and locomotion going for virtual reality. And then after that, I have a few questions, and then we'll open the questions up to the audience. So start writing down those questions as they come up. I'm going to keep my questions short in order to give you guys the chance to ask some of those questions. Okay, with that, first up we have Danny Woodall from Sixense Entertainment. He is actually the creative director at Sixense, and he's had lots of experience in game design for Sixense, over a decade in fact. He's shipped several AAA titles, and now what he's doing, he's working on that next generation of interaction, using that intuitive motion input for virtual reality. I'm sure a lot of you have the chance to try it so far out on the show floor.
Yeah, like what he said. Yeah, so like I said, I'm the creative director at Sixense, and yeah, we make electromagnetic tracking solutions, 6 degrees of freedom devices. You guys are probably all familiar with the Razor Hydra. I'm actually giving a workshop tomorrow about some of the development tools that we're creating for the hardware. So please stop by, and if you do, you will be entered in a raffle to win a STEM system. So again, this talk is really about enabling developers and kind of creating a shortcut for everyone that wants to do the same thing. They want to create this full body presence and have a way to interact with the world. But yeah, so that's who I am. That's what we're doing. Please stop by tomorrow. We actually have our show for presence here. We're showing developer tools. We can walk you through them if you want to see them there. And we also are showing Portal 2 in VR. And then we have Denny Unger from Cloudhead Games, who's demoing his gallery, and it's a very, very cool demo as well. Yeah.
Okay, up next we have Richard Marks, a director at Sony Magic Lab. How cool of a name is that, Magic Lab? And Richard has done quite a few things. I remember first seeing him at SIGGRAPH over a decade ago, showing some of his work that evolved eventually into the PlayStation Move, and that the iToy, along with the PlayStation Move, he shipped tens of millions, I think, of units. So he's been out there and has done that. And Richard originally got his degree in avionics at MIT. As if that wasn't good enough, he went on to Stanford and got his PhD in robotics and computer vision. And with that, Richard, go ahead.
Thanks. So I've been at PlayStation for 15 years, and my major area of research has been user input. Graphics had tons and tons of people focused on it, and display technologies, and there was a lot less focus on input technologies at the time. Then we had this recent revolution of camera-based things and inertial-based systems, so there's now the new input has gotten just as much attention as it deserves, which is great to see. And we have our Morpheus system from PlayStation we're demoing in the Expo if you haven't gotten a chance to see it. I've been surprised a lot of people here haven't actually ever tried the PlayStation Move, which is what we're using for the demo for our input. It gives a really good 6 degree of freedom tracking input that goes along with the head tracking in Morpheus.
Okay, up next we have Goetgeluk from Virtuix. And I just met Jaunt just over a year ago at a virtual reality conference similar to what we have here. And Jaunt has a background in mechanical engineering, and also he has an MBA, so two very diverse things. And he's done some amazing things. We worked together on creating the game for Shark Tank. I think some of you have probably seen over, 7 million viewers saw that, seeing virtual reality on television for the first time. So that was a pretty cool thing. Jaunt?
Yeah, thanks, Jason. So I'm Jan, I'm the developer of the Omni. Started working on the Omni about 3 years ago, way before there was an Oculus Rift. I was actually using old Virtuix glasses at the time. And my main thought was that, I thought the biggest problem that had been solved in virtual reality was a problem of locomotion. How do you physically walk around in that virtual world? And I didn't want to sit down in my chair with a head-mounted display on my head, pushing buttons on a keyboard or a gamepad. I wanted to really walk around in that world and move physically in the virtual world, and that's why I started developing the Omni, which was a long process. Tried a lot of different things, explored every possible way one could build an omnidirectional treadmill, and then now here we are with the Omni, where we are today, and virtual reality where it is today. It's a great position, a great area to be in. So thanks for having me.
Thanks, Jaunt. All right, up next we have David Holz, who is the CTO and co-founder of Locomotion. I'm sure all you guys have heard of, and he has a background. He's worked at several different places: NASA, doing neuroscience research at the Max Planck Institute. He studied math at the University of North Carolina. And I've known David for a little while before Locomotion was Locomotion. We were integrated some technology together with Paul Mlyniec, who will be on the next panel, actually. And I look forward to hearing what David has to say about him.
Hi, so Locomotion, 10 fingers, 2 hands, sub-millimeter motion tracking. We just came out with public beta for our next generation hand tracking software, which involves a skeletal model, so it's a really huge step up. And it's the first skeletal hand model that really gets to this usable, interesting quality that opens up a lot of really interesting development opportunities. It's at our booth. It's downloadable on the internet now. Yeah.
All right, thank you, David. Nathan Burba, CEO of Survios, he's been doing some pretty amazing stuff. I saw a demo last summer of what he's been doing, and he's told me it's gotten even better since then. It's actually a worn device that you can walk around in, so you're not confined to being seated in your chair. And he was also director of the famous project Holodeck out of USC Institute for Creative Technologies. And Nathan, he's an author. He's written a book. He's got a mechanical engineering background. He does software development. He has a film background. He's sort of done it all. Nathan?
Yeah, thank you, Jason. You have read my LinkedIn profile, and I appreciate that. Got a little bit of mechanical engineering, not quite a background. I should actually basically, Survios, user input is really crucial. It's all about whole body input, and really, can you combine that with an amazing output system like the Oculus Rift, and everything you do in life, every motion you make creates this amazing amount of output, and so it just makes a system that's totally different than just using a mouse and keyboard. It really is, something that we've only dreamed of so far. So we're really excited to be building new modes of input and really trying to, with everyone here, trying to pioneer something that's really going to change the world. So, thanks.
Excellent. Okay. Well, let's give a hand to our panelists first. And the first question, just to kind of get this out, you mentioned Nathan, a little bit of experience with mechanical engineering, but including Nathan, 3 of the 5 panelists here have a background in mechanical engineering. And what's with that? Is that a coincidence, or does getting your hands on something, is that important in developing these systems? Are there any thoughts of those that have a mechanical engineering background?
Well, I started working on software applications, and I realized that I just couldn't do it. So I stick to my 10,000 hour rule and stick to what you know, and figured that I should focus on the mechanical problem of locomotion, and that's what I did.
Danny, you have a degree in
Yeah, I think a lot of it goes to sort of a mentality that you get. Quite often I look at something and I look at it not at what it is, but how it can be better. And so I'm a problem solver. I always try to figure out how I can take this one thing and really make minor improvements to really have a gross impact on something. So whether it's with hardware or software, I think it's the mentality that we bring to the table.
So I want to know if this is just a coincidence. How many in the crowd have some sort of background in mechanical engineering? Very different. Interesting. Okay, we'll move on.
Well, one thing is that, sensors are a big part of input, so mechanical engineering involves a lot of using sensors for things. And I think, actually, the difference between some of the other things that are done in virtual reality and used in input are the fact that we have to interact with the real world person that's causing the input, so therefore it's not just simulation, it's actually a lot of mechanical things get involved, a lot of design choices have to be made, and that's why I think a lot of these guys have that background.
Well, that brings up a good point, because you and David both obviously know computer vision very well. Do you have some kind of how thinking about things, not just from an implementation point of view, but as a way of thinking, how that background in computer vision helps with how we interact in virtual worlds?
So how does a mindset of computer vision help with designing it?
Does that imply kind of a way of thinking, like visual thinking?
It's hard. It's sometimes it's a little bit of a. I wouldn't say it's so like computer vision is a lot of things, and I think that more than in some ways I would say it's sort of an applied art where you kind of where there's a lot of math and there's geometry, but then there's sort of the nature of the data. And whenever you work with data, you kind of it's hard to explain. Like you can have a very good background, but if you've never worked with like live data before or live data of a particular type, you kind of have to get your feel for it. And I don't know if necessarily that there's a good parallel between that type of data and the greater user interface problem. But I think the general sort of mindsets of mathematics and algorithms and geometry and software, I think that goes very deeply to what this stuff is going to end up being solved by, or where how it's going to come from.
Yeah, and computer vision is kind of the inverse problem of graphics. It's like taking the opposite approach. It's a much harder problem, we always say, in the computer vision field than graphics, which is super easy because you just draw whatever you want. But with computer vision, you have to invert the problem, which is not an invertible problem usually, so that you'll pose most of the time. But I think that by studying the camera technology and things, it does help a lot actually with the graphics that we can do and the kind of, we have a strong feeling about latency and things like that for computer vision. That also is a big factor.
Yeah, I can imagine it being the inverse of computer graphics. So it allows you to think about computer graphics differently than a computer graphics guy. Different solution. Okay, next question. Well, this leads naturally nicely into the question of sort of the Leap Motion or the Microsoft Connect of not having a physical control, so doing freeform recognition from camera-based systems versus hardware controllers, which also brings up the question of physical buttons versus no buttons. And I know Richard previously has spoken on his thoughts of there's really one being the better of the other, but that it just really depends on the application. Maybe, Richard, we could have you start by elaborating.
Sure, I think each of these input technologies has its place. Buttons are the best for a pure event kind of thing, an action. They're 100% reliable pretty much compared to other things which are more interpretive and maybe are better for more of an analog input or a kind of a quality setting maybe of something. Give a little more stylistic input. It's better for more freeform input, but I don't think it's easy to replace a button. This weekend I was doing some things with a electric saw, and I'm very glad it uses a button and not a gesture as its control mechanism. But of course, to cut, you have to use a little more analog input. So.
I think it's going to be. I think one day, some virtual reality is going to be an awful lot like reality, and sometimes you're going to use your hands directly to interact with the world around you, and sometimes you're going to interact with the world around you using some kind of tools or intermediary. And I like just like how there's an industry for like. Whether it's sort of garage tools or like office supplies, I imagine that you'll have similar sort of sets of objects which you can use to interact with the virtual world, in addition to your hands. And I think that when you have both the tools and your hands directly, then hopefully I think you get something a lot more powerful than just one or the other.
Yeah, that's something we struggle with a lot because obviously it's hard to imagine a single object that matches every virtual object you'd want to interact with. So you don't want that because then you'd have thousands of objects as your input devices. So you want to find a more general purpose tool, but it's hard to find one that is going to satisfy all these things. and your hand isn't actually it either. So it's
yeah. I can imagine like a toolkit one day. Like at some point, if accelerometers get cheap enough that you could almost just have like 3 things accelerometers in them, or at some point, maybe if they are somehow optically marked, then if the optical tracking can track hands, it could probably track props, and then you can imagine actually just like almost like styrofoam. At some point the props literally just become like plastic, and then it's not really a matter of expense. So that's something that definitely is a little dream line.
I think also with 3D printing, it will be more easy to print different forms. And then you have, for example, the Sixense stem technology, where you have more of a general controller, which you can just fit into whatever weapon or gun or object you like. And so you'd have more of that diversity of peripherals available with just one core technology if you want to.
Yeah, I think things have coalesced around that. I think 90% of the things you want to interact with in a virtual world is basically it's shaped like this microphone, and people forget that things that you hold, they give you haptic feedback. This is haptic feedback. This is one of the primary modes of haptic feedback that we typically use. So I think that plus some sort of motion, possibly plus some sort of digit tracking. I think there's a potential holy grail there somewhere. So if someone puts that together in the right formation.
Yeah, I mean, I think a lot of it really, again, has to do with the application, but one thing I am excited about is having this more natural interaction with hand gestures, where you can look around. Typically, you might walk up to a light switch and you're going to get a button prompt. You turn this light switch on, you press the button, and it happens. In 2D, when you're looking at the screen, yeah, we kind of just accept that that's how things are, and we've learned to be trained in that way. But now I put you inside of virtual reality, and that whole execution just doesn't work anymore. That presence you once had is suddenly gone. And now you don't even really need it, because you see a light switch and you know how a light switch functions. So you walk over to it and you flip it and it just works. So I'm really excited to see those kind of revolutions happen in our gaming world, where we can kind of quit being treated as kind of stupid people that need training in every little thing to interact with, and things just become more intuitive. I think it also raises the problem, if you do have all these types of peripherals that make sense depending upon the application, well, how do you interchange them while you're in VR? Because where are they? Are they strapped to you, or are they here? So a more general solution, is probably best for the more generally, for almost everything. But there's going to be those special cases when you might want a peripheral that really makes it feel like you're holding, something long, a sword that has some weight to it or something. I think they all have their place.
Yeah, we've definitely found that having something like a trigger feels really good for grasping. When you squeeze on it, it really is a good analogy to grabbing. And you don't really have to explain it to people the first time they squeeze it and they see something react. It's really important to have visual feedback of what you're doing so that you can understand what's happening. But then once you have that, you don't really have to even explain it anymore.
Just one controversial point maybe is that I think a lot of people think of in terms of interaction right now with virtual reality is sort of skeuomorphic virtual reality interaction, where it's like you're picking something up like you would in real life. You're turning a knob like you would in real life. Everything is very similar, and I think at some point people are going to be like, do I have, it's like, oh, I have to pick it up. That's how passe. Like, it's gonna, and at that point we're going to start to ask ourselves, like, what can interaction really be independent of reality when we have all these tools and all this data? And I think that might actually go into a completely different, interesting direction. And that's something interesting to think about.
Yeah, I mean, to David's point, virtual reality simulates fantasy, it doesn't simulate reality. I mean, no one wants to turn a knob. I mean, I don't care. I'd rather just say something and my door opens, or touch it and it opens. That's just something we have in reality. So we don't even need to simulate that. It's all about simulating a fantasy of feeling something. Like in Zombies on the Holodeck, it's a fantasy of shooting guns. They don't feel like real guns, there's nothing like real guns, but they simulate the fantasy that people have in their head of shooting a real gun. So that's the key, is to simulate the fantasy.
Yeah, and one really great thing that kind of straddles between there is like the force power, where you still do something that's like turning the knob, but you don't actually have to reach over and turn the knob, so you just gotta go like that and turn the knob. That's a great in between.
But I think that haptic feedback is important. One thing in the early days I was working with Mlyniec a lot, and what you notice is that not feeling anything, not feeling any buttons, not feeling any triggers, there's something missing. And so that feeling is important. So whatever it can be, I think just gestures won't cut it. People want to feel something.
There's one interesting thing that we found in testing, which is that Very often, it's people seem to like care more about the result than the needs. And if you have two things which take a similar amount of time, it's sometimes controversial as to which really takes precedent over the other, which people choose. But if at any point you can make something better or faster than the other thing, like something flips in somebody's brain, like what I mean is like if I can pick up that glass by reaching over and grabbing it, or I could do it like this at a distance, because this at a distance would be faster, something usually flips in the person's brain and just says, well, that's natural, I'm okay with that, because it seems like that the brain really cares about the result more than the actual act sometimes. So there's some weirdness there, maybe like psychologically, that we'll start to get into if we can actually make something better.
Well, it's a combination of that and also making it intuitive so they know to do that right off the bat. So if they know to do something, they do it quickly, then you're done. It doesn't matter how they do it.
Yeah, intuition. I like that word. That brings up a point for, I guess, the camera-based systems, although it could also be the controller-based systems for gesture recognition. Do we need to be at 100% consistency? So if I'm like flipping on the light switch, 99.9% of the time, you know when you switch it on. Is gesture recognition something we need to be at near 100%, or for some applications, is it okay if it's 90–95% of the time?
I think it needs to be very close to 100. I mean, especially for games. I mean, in particular, like if you try to once again shoot that gun, whatever it is you're doing, and it doesn't work that one time, you're gonna go, this damn system, right? Even though it's one time out of 10,000 or something. So it needs to be pretty high, in our opinion.
Yeah, it's gotta be really good.
I think if you're trying to use gestures to do an action, then that's true. If you're using them for a modifier, then it's not so exact that it needs to be. So it could be the strength of something, maybe. Or like when I talk to you, I use my hands. There's no exact answer there. It's just a modifier. So it depends what you're using it for. I'd rather use buttons for the actions.
Yep, it's a good point that it's very dangerous to use, I think, gestures as sort of buttons. And then that's the danger about the word gesture is that people often end up using it like button. And that's sort of implicitly using one interface to be another interface. And I think that it's really important that in building all these new interfaces, we really ask ourselves, like, what is sort of the art in each of these new interfaces, and what is the sort of specialty and value? And we can do that, but it's definitely one of the more dangerous things.
Okay, with that, we'll move on to more of the locomotion aspects. I'd be interested in hearing your thoughts on, is that different people are navigating through these virtual worlds based on their input in different ways. I mean, we have real walking, like Nathan is doing. We have treadmill, omnidirectional treadmill walking. Jaunt. We have sort of the make VR navigation that Danny and Sixense have done. And then we have kind of the traditional virtual reality input, like point to fly sort of navigation. Is there any thoughts of the trade-offs between those different ways of doing navigation?
Well, I'll start because I think there's a lot to be said about, and the question is supposed to be a lot, the question of seated VR versus non-seated VR. And you can guess my preference. I prefer non-seated VR, but I clarify, I do realize that seated VR is a great starting point. And then I do understand the importance of getting seated VR right first, as opposed to right away complicated virtual reality. And also realize that some people might prefer seated VR, have no interest in ever walking around in virtual reality. And that is fine too. But in my experience, we talk a lot about presence and the feeling of immersion. And Mike Labrush has his white paper about presence, and it's so important. But the reality is, in my experience, just standing up out of your chair vastly increases the feeling of immersion. And then rotating your body naturally, that increases the immersion. And then you put one foot in front of the other and you start walking, and you're walking in virtual reality. That increases the immersion by quite a bit. And I think it's a great experience. And ultimately, seated VR is a great starting point, but some of us might want to do more than that. And I didn't want to sit down in a chair and push buttons on a gamepad or a keyboard. I wanted to walk around naturally. And that's, I think, the evolution of virtual reality. That's where, for some of us, maybe not all of us, but some of us would truly appreciate that higher level of present immersion that creates.
Yeah, I mean, I have to completely agree with you. When I tried that one and I was moving, and I got this natural head bob, which we all used to recreate in 2D. But now I've really got this head bob, and I'm feeling myself go, and I'm seeing the world go by me, and I feel like it's me doing it. It was a huge connection. It's the same kind of thing, like though you can't be standing in all these types of applications. Say you play Star Citizen, you're not going to be standing in that because you're sitting in a cockpit. Sitting in a cockpit in a chair makes a lot more sense. And then the locomotion is purely driven by your ship, right? But you're talking about human locomotion. It's a much more complex problem, especially if you're playing GTA. You can stand up and sit down and stand up, and, all these types of things. I think the traditional analog stick approach it works, but it doesn't work in the sense that you can put someone fresh in VR right into that situation. They almost always, do a staggering side effect because things aren't, working in their mind. So yeah, I think that something needs to happen in terms of locomotion in the vast majority of these, standing and walking around. I think a treadmill really works in many cases.
I certainly think it's going to be limited without some kind of formal locomotion. I think we're already seeing that, where it's we have a lot of the in the seat experience. You often have to have sort of seated games that like you can't really move around, or you're in a cockpit, or or there's something in front of you. And I think that in those situations, it's kind of it's hard to tell that you can't walk around because you're not supposed to walk around. But so you can definitely design around it. But I do think that if you're actually supposed to be walking around, then actually walking around is certainly it kind of takes the core part of that experience and makes it real, which is really interesting. And personally, I can't wait till I can have sort of and take my computing kind of around with me and actually sort of walk in the real world and the virtual world at the same time. Like there's something interesting about that.
Yeah, I mean, you can all see where virtual reality is going at some point, being mobile, and having a tether-free experience, and being able to have locomotion where you kind of physically walk around, and interesting applications are going to be developed around that. Where it could be in a confined space, where you can map the space of your room, maybe scan it with some technology, and really bring that room into your virtual world.
Yeah, and I'll say that I agree with Jan. Standing up is really, really important. It's what human beings are fundamentally designed to do. That's kind of the approach that we take as we look at what are human beings, what do we evolve to do? We're evolved to run, jump, hunt, collect, all of these things. These are things that games do really well because games are very fundamentally human. So it's same thing with virtual reality. You're much more there when you're standing up and you're doing those very human things. And so that we look at it less from a computing standpoint, more of a I'm a human being, and these are the very fundamental, intuitive things that I like to do. And
it's a really good point. A lot of this is about it's not just input and output. A lot of it's about making technology work and actually moving around and acting like a human with technology. So,
We've done some things because obviously it's a challenge I can't actually walk around with systems that are tethered very much. So we've done things where you use accelerometers that are there to see a signal of something like a step. It's not a real step. Mixed results. Some people really like it, some people don't like it. I'm sure you've looked at that.
Yeah, because what I would say there is that to really trick your brain that you're walking, it's very important that one foot moves in front of the other. When they're walking in place, your brain realizes that you're not really walking. But the moment that you start putting one foot in front of the other, that makes a big difference.
We have a really neat demonstration that uses the move that Anton created, so I'll bring it up. It's a chameleon simulator. So you're hanging from a tree branch, and you reach out and grab the next tree branch with your hand, and then you use your hand over hand to walk across tree branches. And that feels really good, actually, because you feel like you're doing exactly what you should be doing to locomote.
Yeah, that's very much like what we've done with Make VR, where you're reaching and you're actually moving the world, right? You're kind of grabbing and pulling it to you. And you have this correlation of translation, and that definitely works. And I think again with the whole standing versus seated thing, it's presence is so fragile, and what doesn't feel more right than standing at your calibrated height, and versus the game, you're really tall, you're really sitting in the chair, and something just breaks.
I'd like to add something because most people might not realize this, because a lot of attention also goes to positional head tracking. And the head tracking solution, positional head tracking solution of the Oculus and the PlayStation movement that you're using right now. if you are in seated VR, and all you can really move is your head, positional head tracking is very important, because if you don't have positional head tracking, something is clearly missing. My experience when, and maybe I'd like to have your input as well, if you're actually walking in virtual reality, and you're moving and you're in it, and you're walking in VR with your whole body, positional head tracking is actually not that crucial as people now believe it is, at least to a certain extent. Do you have the same experience with zombies?
Well, I mean, I think positional tracking is, I mean, it's pretty crucial. I think it's what solves some of the nausea issues. But I mean, yeah, with zombies, when we had versions that used the Hydra, you didn't have the positional tracking. You know what it is? It's better. For whatever it is, it's kind of like, and this is totally random, but you know when you drive in your car with your dog, and your dog like stands up in the back seat, and he's like, sit down, dog. Why don't you sit down? And he just kind of stands up to get his equilibrium. It's the same thing. When you're standing in VR and you don't have positional tracking, you kind of feel a little bit better than when you're sitting and you don't have positional. I don't know what it is, but it's just a human body thing. So I do see what you're saying there.
It's certainly important, no doubt about it. And virtual reality will have positional head tracking, no doubt about that either. Either when you're seated or you're not seated. But when you're seated, it's even more important.
Okay, guys, we need to move on to the last question. Maybe if each one of you could say it briefly. What are the biggest challenges based on your experiences? What's the biggest challenges you've had with user input, user interfaces, locomotion? And then we'll open up the questions tomorrow.
I think for me, what I see often when I go to these types of shows and I put a headset on somebody is, especially for someone who's never tried VR, you put a headset on them, you give them some motion input, and then you put them in this really fantastic world. Like they're just overwhelmed. So how do you ease people into VR? I think those types of experiences really need to be developed, and really, you have like these are the first VR experiences you should try to kind of get. They can't last, and if they can't last for 5 minutes, you aren't as compelled to go back. And I have a few developers that still cannot be inside of the DK1, even though they really, really, really want to.
Yeah, we talk about presence a lot in VR, and most people focus on visuals and maybe sound a little bit, but really there's another huge thing, which is, like you said, when you first put it on, the first thing you do is try to touch something, and then it breaks because you can't touch it. So we found a really strong, another way to achieve presence is when you cause an interaction in the virtual world that feels right. That's a really compelling thing. And you can see your hands floating in space in front of you. In the VR world, they move, similar to what you're doing with your own hands. That's another form of presence which can override some of the problems with the visuals or the audio that are there. So it's equally compelling.
I mean, just to add real quick there, I remember once I was developing some stuff in VR, and I reached out to interact with this virtual plant. It just so happened that my wife had moved our physical plant, and those two made contact at almost precisely the same time. I got through the headset off and just overwhelmed about like how awesome that was, and I was like, well, how can I make this happen? Of course, we just can't do that. But that really goes through like how much tactile input is really going to add to this experience.
I have a quick comment on that. So at UNC, that's what we did. We match physical objects, passive haptics, to be registered with the virtual. And so you could reach out and actually touch things in the same way. And so I was doing a medical visualization of a head, a medical data set. I brought my girlfriend in, and she looked at the head, and then what I did is I moved my head over to the location and said, okay, reach out and touch it. She reached out and touched my head, and she kind of freaked out.
So the haptic thing is a very hard thing to achieve, but your action can cause a reaction in virtual reality, and that's a really powerful thing. It's, I guess, what the part I meant before that is achievable now is that you cause them to do some action, and the reaction that happens isn't just purely I move my head around, it's more than that you change the world somehow. That's a powerful presence.
I think the biggest challenge with locomotion devices is how to keep the cost down and keep it affordable for consumers. And what we did is we eliminated all the moving parts. A lot of our backers, they want the supporting to move up and down, and as the virtualizer does that, moving parts increase the cost, increase maintenance issues. There's a device here on the show floor which uses the moving belts, which is the true definition of an omnidirectional treadmill. But all of that is very expensive. So the main challenge is how do you make a locomotion device that is somewhat affordable. It's still not cheap, but at least we're trying to get to the point where the consumer can buy these devices.
I think the biggest challenge for a lot of input right now is sort of first getting a lot of the content and framework developers to think of the input, like sort of the virtual reality input in terms of sort of reality inputs, was making things more physical often in order to make them intuitive. But then the next barrier beyond that is sometimes getting them to let go of that and say, it doesn't have to be physical. It can be sort of, or it doesn't have to be real. It can be sort of ultra real or sort of beyond physical. And that's definitely, there's sort of these two mental blocks that a lot of people that I think hold a lot back. That's definitely the biggest challenge. And so it's at least it's not even technological, it's mental.
Yes, one big challenge that we have, not just with Locomotion, but with physical interaction in general, is the feedback system that you use when you interact with the virtual world. Because you can tell something like your arm that it's actually over here because it's pressing up against something, but how far you can push that before it breaks immersion is a difficult thing. And then the actual physics programming to make that seem realistic and work that into your system is very complicated. And so really it's like we kind of understand the design side of it, it's just the programming side really is not trivial at all. And what the general use case for that is a big challenge. It's one of the challenges.
Okay, we'll now open up questions to the audience.
I would like to start, please. Gotta leverage my something somewhere. All right, excellent. A lot of the conversation that's been going on here has been focused on the consumer product making it affordable for the consumer. Yes. However, a lot of people out there, like thousands of people at Maker Faire that were impressed with VR, are probably not going to go out and buy a $2,000 gaming PC or a PlayStation 4 for that matter. And so there's been talk of the rise of the VR arcade, the VR center, having the omnidirectional treadmill in gyms, so kind of more of those perhaps more expensive but nevertheless working solutions. Are any thoughts about that?
I personally love to see that because I think a lot of virtual reality right now is being held back by sort of being a little too price conscious for consumers sometimes. Like people are really nickel and diming the virtual reality experience. Really, I mean, not on all fronts. Like even like when we make hand tracking, we'll try to make it a few dollars cheaper sometimes. And it happens on. And that's the nature of consumer hardware. And if there was some step beyond that, I think we could see some really cool stuff like that.
And to your question about the arcades, we get several emails each week from people that want to start a VR arcade. And I want to buy Ani's food in the arcade, and I'm sure Sixense gets the same request. So I think we will truly see a renaissance of the arcade in a VR context.
I'll say that the business model for arcade is fairly difficult. You have to move people through it very quickly to be able to maintain it. That's why Disneyland literally has rides where they time how fast the rides go based on the space that they have, for the rides to get people through to make money. So I think someone needs to solve that problem to really be able to make money off of that and have it be a viable business model to then move forward.
Well, it depends on what country you're in too.
Right. Exactly. We only care about the United States, and we only care about California. Actually, it's very expensive.
All right. So I'm Jaunt from IMView. We have a large 3D online chat experience. And when we put IMView on the Rift, we learned a few things. One is that it's very hard to type when you're wearing a scuba mask. Another thing we learned was that in IMView we don't have physics by explicitly choosing not to have physics because it confuses sort of the mass market that we're targeting. But as soon as you have that mask on, you really want to move. But if you put yourself in the world, but all the hardware you have is the mouse and the keyboard, and if you're lucky, our customer may actually own a gamepad. So you're all talking about new, fancy, great hardware that is going to be under my Christmas tree in 2015. But for the vast majority of people where that is not an immediate option, what can we do with the stuff that we already have? I would really like to understand that.
What can we do to already have in reality? I mean?
Yeah, we have a keyboard and mouse. Is there a way of making that work better?
The keyboard doesn't work well in virtual reality.
Yeah.
I think It's really hard. Yeah, I mean you can't even see it. At some point there'll be cameras in virtual headsets, then you can see the keyboard. We experiment that, it works great. But until then, it's really tough. You can buy Locomotion or Best Buy right now.
All right, good pitch.
The default for our system is different than your system, right? For the PlayStation 4, the default is a gamepad, and we don't have a keyboard now, so it's a different system. And that gamepad is trackable by a camera, so the default would be starting with something that is pretty good already for actual deal.
Much better than keyboard.
All right, so, okay, David.
I think one of the biggest potentials for VR is for it to be a truly social platform. But the problem with that is the fact that most of our interaction, with 2/3 of our interaction, is non-verbal. So I guess the question is, how soon do you think it will be before we're able to get accurate motion tracking to get to the point where we can actually have true social experiences in virtual reality?
I think there's two parts, there's the body and there's the face.
Both.
The body, arguably you can do it right now with even something like Connect. I think it will get, in the next year or two, I think it's going to become like, it's going to get to the point where it's like indistinguishably real good. But then there's the facial expressions. I think there's a little bit of difficulty there as long as we're wearing things on our faces. I think the first thing we'll see is eye tracking. And with eye tracking, like even if you can't animate the face, the eyes will move around, right? And I think that'll probably help a lot. But then for like mouth tracking, I'm not, so that maybe it'll be like a Connect type of thing, looking at your mouth and then still eye tracking to animate your eyes.
Yeah, we have a 2-person tech demo where you have your hands and your head being tracked, and you're actually shooting coconuts at the other person, and then you have the shield and you can block them. And actually, just the motions of the person's hand and their head, you can tell who it is you're talking to, kind of, or that's a microphone as well. But you can really see those gestures and those things, and it conveys a lot of very strong personality.
I think it's going to be really interesting too, like how do you deal with AI at that point, right? Like we have it now too, where you have this cooperative experience with two human players, and you give them steady controllers and grip tracking on their head. You can tell right away, just like you said, this is not automated at all. Yeah. And you can do things like come over here or over there, or lots of gestural things just talking. It really adds a lot of social aspect to it. But now like you can have these. If there's nobody in that world, like how do you? It's going to be quite obvious that this is an AI and not someone in there with you, which might not feel that great in a virtual environment, right?
There's definitely a sense of presence just from like motion kind of acting, right? And it's really interesting. Like you can kind of feel the person behind the motion. It's weird.
Yeah, I remember seeing one of my engineers, Owen, join the test with us, and I saw him get in the Rift and look down at his hand. His head's moving around, and it was exactly what he was doing in real life. It was sort of mesmerizing as a third person to look at him. It's cool. I only saw it first person, so it was really quite compelling.
One thing we forget about too is space. If you're actually, you're there, I'm here, he's there. That's something that games have been doing for a long time. You play it, you shoot it online. So virtual reality can bring that in as well to add even more of the natural human, That's something that any network game can do. So I think you put all those together, you see something like what Philip is working on with high fidelity is just, you feel some of that just in the presentation. It's awesome stuff.
Yeah, the surprising thing is when we render just the hands and the head and no body at all, it just kind of works anyway. It doesn't matter that the rest of the parts are missing. Video games have done this for a long time where they don't render all the pieces to make lower polygon counts and things.
It's amazing what you can get away with just with head tracking. If you watch Sesame Street or Muppets, some form of Muppets, usually they don't have eye tracking or even eye blinks. And to add on also for the mouth, you can do something as simple as the amplitude of the microphone. You're not necessarily getting the smiles and all that, but just that small amount can actually add quite a bit. You can easily do that within Unity.
Cool. Thank you.
Very interesting panel. I'm a user experience designer, and I worked on a multimodal interface for medical data recently. And I noticed there was some areas where voice commands and gesture, were obvious breaks where one thing made sense and another one didn't. And there are places where it was more nebulous, and there are also the transitions between voice and those things. So when you're talking about sort of the new intuitive kind of approaches, how do you think about them? How do you test them? And what kind of resources, as far as style guides and design pattern libraries, do you rely on or do you create that sort of work with these things?
In terms of voice and gesture, I think I kind of think categorical is the place where voice makes a lot more sense. And something or grammatical. So it's like, obviously, show me the last episode of Star Trek I haven't seen. Like, I should be able to say that to my TV, should be able to do that, and that's going to be a huge thing to do with gestures. But the second I want to pause the video, rewind, mark this part, or mark this part and grab a clip out, like that was something that was just totally impossible to do with voice. So I think we're going to find that like sort of spatial, temporal tends to be sort of hand-based, and categorical, grammatical tends to be verbal. In terms of user testing and design patterns, it's really, so I mean, it's easy to just, you can get people and you can user test gesture control just like you can user test anything else. There's some, I think the biggest problem is not like rather, not the ability to test something, but rather the space in which to, the space of possibilities in which to test. And the other thing that's probably the most difficult thing is just prototyping. So there are a lot of tools people use to prototype things like GUIs. You know, they can draw it on a piece of paper, they can get like, you know, sketchpad, like these sticker things. But there's nothing like that for, you know, motion, for these sort of motion interfaces, because how do you sketch something that's in motion in 3D with depth? And I think that that's something, that's a really big, interesting open problem. In some sense, it makes it so that the prototypers have to be coders, but like you can't really have an artistic prototyping stage. That's probably the biggest challenge. And so what we'd like to try to get visual effects artists maybe to help there, but that's something that's still a work in progress. In design patterns, it's mostly just we kind of have a list of them kind of going up on the time. I think a lot of it comes down to, in the simple and really briefly, it's just like don't only have one way of doing something, with hands at least, because there is more than one way of doing things with your hands for really everything. And so it's more, sometimes it's more about the synonyms than it is about the gestures. You know, it's more about having more than one way of doing something. It is about picking the one right way of doing it.
Yeah, I think you also need to understand the limitations of the systems you're working with. So what can it do, what can't it do, what is it really good? You know, if you're just saying to your Xbox or your TV, stop, play, rewind, and it can hear the best part of everyone say those words very clearly, very easily, then boom, you got it right there. So, but you have to understand what it can and can't do, and then that will guide you most of the way, in my opinion.
Voice commands are very challenging too, just in the very essence of, you know, we all have different accents, and them being understood or being interpreted when you actually didn't say them, and a menu pop up or something. Like it's a very challenging problem that we haven't quite solved yet. I think we've made a lot of progress, but we're still.
Even Sierra doesn't understand me. So.
Richard, you were at Neurogaming, I guess, so BCIs. I don't know if I the word, but.
Well, I'm not going to address that maybe, but the only thing I was going to add is for voice, the biggest win is it's random access. You can access anything with, you know, a very small amount of input, and that's really what the win should be. Because I haven't quite delivered on that all the way, but for navigating menus and things, it's not very good for that. I think because it's hierarchical and it takes a long time. So, but random access straight to one thing that's really kind of long tail is really what voice should be good at.
Okay, unfortunately we're running out of time, so one more quick question and some quick answers.
So what does it feel like to fly? I want to fly, right? I don't want to put one foot in front of the other during this keynote address. We moved around in the area the size of San Francisco. We're looking at potentially infinite worlds that we're moving around in. How do we handle the conflict between the need for our physical presence and some realism as opposed to wanting to fly like a bird?
Guys should probably know the answer to that best. I've seen right over there from DreamWorks, and they made a How to Train Your Dragon flight simulation for the Oculus Rift. And they actually got a lot of great things that they learned from having people try it out.
I think it's like if you ask what sort of our kids will be doing, they'll be flying. Like it's like a lot. I think it's kind of all the guys that are going to be holding back a lot of these sort of like the way that people are when you remove them from reality. Like that's sort of what we really have. Like what are people when you really remove them from all constraints? And like, I think you'll see that, you know, the limits of like space and like in concepts and like even senses, like sight won't necessarily like sound, like the colors won't necessarily be colors, sound doesn't necessarily be sound. These people will grow up in environments where they can sort of interchangeably switch out the realities to any different sets of things, and like that's gonna be sort of flawed.
It just went to a fascinating place. I could just stop real quick. Wild Skies had a specific thing where two players could get a ship together, Project Holiday Days, and the back person on the ship who wasn't flying it actually would almost fall over when the first person started flying the ship, because the horizon shift would make it feel like you were flying. So it was pretty cool, I guess.
Yeah, and flying in virtual reality is probably one of the most common, maybe not today, but in the past, in the 90s and stuff, was one of the most common ways of interacting. And it worked great in some situations, but when you needed precision or you flew past something and needed to move back, it sometimes was quite challenging. Again, I think it depends on the application.
The thing I learned from the DreamWorks guys was that the most important thing about flying is having your feet not be touching the ground while you're doing it. Best feeling.
Yeah,
Okay.
maybe that's why falling works instead of flying.
Okay, we are out of time. If we could give our panelists a hand. And we can move the conversation outside of the room. You guys can continue talking with the panelists.
Thanks for having us.